Hey guys, welcome to day 9 of the 28 days data science AI and Gen AI challenge. It's me Mahesh, having 14 years of experience in data as a data architect, data scientist, data engineering and data trainer. So today I'm going to talk about neural networks. So before all the things what we have done in the past days, we were working on traditional machine learning models. Okay, there were a few issues in machine learning models. For example, something called model decay. So what is model decay? Technically, model decay means that as we go ahead with the time, what happens is that the performance of the model starts reducing. So to handle this kind of situation, we again came up with the concept of neural networks. But at the same time, the other issue was complex problems. So if you have noticed, the data which we have worked in the past mostly were in some kind of structured manner, okay, but as the world goes ahead, we have images, we have videos, we have text, we have PDFs. So to handle these kind of situations, right, we came up with the concept of neural network. Okay, so now what is neural network? Technically, the concept of neural network says that try to mimic the idea of brain. Okay, so that's how we'll start the concept. Okay, let me go to the next slide and try to explain you what is neural network. So as I was saying, the concept is to mimic the brain of a proper human. So it is something like a mini brain which understands the pattern, and based on that it tries to give you an output. The best example would be, try to understand example of a coffee shop. Okay, in a coffee shop what happens is that you give an order, like for example a cappuccino. Okay, so what happens behind the box, the order of the cappuccino is processed and required ingredients like milk, coffee, water, sugar are put forward, and then the output comes into picture, which is a cappuccino. Something in a similar sense, what happens in a given neural network, there would be an input layer, there would be a hidden layer, there would be an output layer. Input layer takes the required input, for example the features and stuff. The hidden layer processes the data, recognize the patterns, and output layer technically delivers that results to you. The important thing in this, which is very interesting to know, once you understand input layer, hidden layer, output layer, is the activation function. Activation function decides what kind of neuron is to activate. Is it a sigmoid? Is it a ReLU? I understand if you're hearing this concept for the first time, don't worry. I'm going to explain about ReLU and sigmoid. If you need, I can explain right now, or if you need, I can explain in the next videos also. Now, if you understand this much, so the feed forward network, technically this is the architecture which you need to follow. It would have an input layer, it would have a hidden layer, it would have an output layer. In the given example, what you can see in the diagram, it has one input layer, one output layer, but two hidden layers. It is possible, right? We can have multiple hidden layers based on the complexity of the problem statement. Okay, so now what I'm going to do is that I'm going to showcase you a Google Colab link with the code in it, which I'm going to build a very simple neural network in it. Okay, it is going to use PyTorch libraries, right? I've taken forward California housing data set. It consists of 8 features, and we are trying to predict the right price of the house. Okay, very simple, very straightforward. Okay, right now we are not using any complex data structures, like for example the images not. So in that kind of scenarios, when we are using neural networks for structured data sets, it is called as ANN. Okay, remember that. Now once we understand the different concept of neural networks, which is ANN, CNN, RNN, as we go on, and we are going to increase the difficulty of it. Based on that, we have multiple applications. For example, we can create computer vision, we can create advanced NLP concepts, we can have an advanced financial concept. It can be also used for healthcare kind of stuff, okay, which you would have already seen happening in a lot of newspapers, in media. You would have seen how AI and how deep learning is helping out in various applications. In the same sense, so technically what is happening is that they are using deep learning neural network as a base, and the complexity keeps on increasing. So for the time being, what I'm going to do, I'm going to show you a very simple example as an understanding purpose. As we go on, the idea or the challenge would be, take this code, try to run the code at your end, and let me know if you have any challenges and all. Okay, the code is going to have structure based cells, so it becomes very easy for you to understand also. Now let's jump into the code. Today is day 9 and this is the code for the neural network basics. Okay, as I have shared the last time, so what I have done is that I have put forward all the links to my Discord server, the GitHub, the YouTube link, LinkedIn. Okay, there are multiple spaces where you can come forward and put forward your queries. I'm happy to answer those queries. So like every time, I've put forward the whole code. I've divided the whole code into different cells, and every cell consists of what exactly we are doing. Okay, so the first cell, it talks about the important libraries which we are going to import. Remember, the most important is the torch one. Okay, the torch is nothing but is called the PyTorch. It consists of the neural network and the tensor operations methods within that library. Okay, and I think so all the other thing is very straightforward. The one more thing which I like to add here is the California housing data sets, which I'm going to take it from the scikit-learn library. Next is technically we are loading the data and doing the pre-processing of data. Okay, so in terms of loading the data, as I was shared, I've got the data from the California data sets, which consist of 8 features, something like median income, average rooms, and the target is nothing but the actual price what we are trying to predict. Okay, so I have split the data in training and testing, 80% in training, 20% in testing. We have normalized the data with the help of standard scaler. Okay, if you have any query anywhere, please let me know in the comments. Okay, the next step what we have done is that we have defined the neural network. Okay, in this we have put forward that our neural network is going to consist of an input layer, a hidden layer, and an output layer. Okay, if you come here, you will understand that in input layer we have taken all the important features, or you can say all the features which are available for our California data set, which is 8 features. Then I have taken 10 hidden layers. Okay, and then I have put forward one output layer. In this 10 hidden layer, I have taken relu as my activation function. Don't worry, I'll explain about the activation function in the next day challenge. Then I have put forward my loss function definition. Okay, for my loss function, I defined mean square error as my loss function. If you don't know about the matrices in regression kind of class problem statement, do let me know. I'll talk more about it. So we have used Adam optimizer. When we are going to explain about different activation function, at that point of time, I'll talk about Adam optimizer too. Then what I have done, I have trained my model. Okay, remember that when we are talking about neural network, the most important thing which happen is that a backward propagation. Okay, in this you will see that there are multiple backward propagation happening. Okay, so we have created a loop for that. It's called epochs, which is somewhere around 500. So model makes the prediction, does a forward pass, the loss is calculated using the MSE, then the gradients are computed with the help of backward propagation, and then the weights are updated using the optimizer. In tomorrow's challenge, I'm going to go a bit more deeper around it and going to explain a bit more better. Okay, so technically let's take it as a base one for the putting forward the base of neural network, and as we go I'll uncover the depths of neural networks too. Okay, after that what I have done is that I put forward a visualization for you trying to explain you how the losses are reducing as the epochs are increasing. Epochs can be also put forward as a loop. So as the loops are increasing, multiple backward propagation happening, how the loss portion is reduced. Okay, then what we have done, we have tested our model. Okay, so we have evaluated the test data, we calculated the test loss to the measured performance, and we compared the predicted prices with the actual prices using a scatter plot. Okay, so you can see here the red line represents the perfect predictions, and the closer the point to this point is better the model. Okay, so this is what we have right now. Okay, if you have any question anywhere, please let me know. I'm happy to share my feedback in the comments, and if you want to talk to me directly, let me know. Thank you guys. If you have reached till here, it means that you have finished the video. Thanks for watching and being part of the 28 Data Science Challenge. Your support, engagement, and enthusiasm make this journey even more exciting for me. If you found this valuable, drop a comment, share your insight, and tag a friend who should join us. Let's keep learning, building, and growing together in the AI engineering space. Make sure to like, subscribe, and stay tuned for the next challenging stuff what is going to come tomorrow, because we have just started and it's going to get better and better as we go. Bye.